Hello and welcome to Talking Points. I'm Dave Kelly, Director of Advanced Media Production at Cal State Long Beach. Today we'll be talking about the dynamic new world of 3D printing. We'll discuss how this technology will revolutionize the design and manufacturing industries of the future. My guest today is Mark Trageser. Mr. Trageser is an inventor, a designer, and an entrepreneur who utilizes 3D printing applications extensively in his work. Welcome, Mark, and thank you for joining us on Talking Points.
It's good to be here. I'm happy to tell you about the future.
Very good. Well, I saw a little bit of the future because you gave a presentation to a group of design students and we videotaped it. I took a look at that videotape presentation and I have to say it was a very spirited presentation. You were very encouraging for the design students. Essentially, you told them the sky is the limit and for 3D printing. We'll talk about the sky being the limit a little bit later, but first we should probably define for our viewing audience what we mean by 3D printing. Some people have heard about this. Some people may have seen a demonstration of it but don't fully understand it. So for the benefit of our audience, explain what is 3D printing and how does it work?
Well, 3D printing, there's a lot of different types of machines, but essentially it's taking and building an object in layers. So you would have a machine and you would build this up layer by layer. So you'd start at the bottom and the software slices it, and then the machine just builds a layer, drops it a little bit, builds a layer. And so you can actually see ridges in this piece here that shows how it was built up from the bottom.
Okay, and there are different kinds of 3D modeling machines and different kinds of techniques that have developed over the years. I talk about it as a brand new dynamic industry, but actually in one form or another we've had some variation of this for probably about 3 decades. And we had stereo lithography, for example, back in the 1980s, developed by a man by the name of Chuck Hull. What was stereo lithography and how does it link to what we're doing today?
So stereolithography is just a type of 3D printing. It uses what I call basically magic liquid, and then it uses light to cure that. So in the same way that some machines, it builds it up in layers, but you have a liquid, it's cured, and then you move it a layer and you cure another layer. So again, building in layers, but in that specific technology, you're doing stereo, which is levels, and lithography, which is you print something with light.
And we also have what's called fusion deposition modeling.
Yeah.
What is that exactly?
So fusion deposition modeling is actually more like this first one where you're building it up in layers. So I can show you this was actually built with an SLA machine. It has high resolution, but it's only made with one material. In this case, this one was made with fused deposition modeling, so I had to build it a little bit differently. And you can see that it has the ridges in it, but it's a much stronger part. Other machines, like this is an SLS part, this was made with nylon and laser dust. Lasers bonded nylon dust together to make this one. And you can even print in metal. So these are all the same file, but that one was printed in metal, that one was printed in plastic, just off of different machines. And we can even go further when you bring in other technologies, like this is water jet cut, and that was made from steel. And this is cut from wood using computer-controlled, numeric-controlled cutters.
Now, when we've talked in the past, you've said that 3D printing is maybe not the most appropriate term. A term that you've defined as digital fabrication might be a better term. Why is the term digital fabrication more appropriate?
Well, there are so many different types of printers or machines that work. So for example, the wood you saw before, that's a subtractive process where you're cutting something away. These machines are additive manufacturing because you're adding material. So it really isn't a printer per se, but it's a good enough word for now because it covers a wide territory.
There's a range of things that can be done with 3D printers. Now we're going to talk about the sky being the limit. Give us a sense of what that range is. What are some fairly typical low-end products and what are some of the high-end products that are being developed today?
Well, to give you a sense of the range, we're talking people are developing printers that are printing DNA, the smallest thing that exists, and people that are printing cement houses. So right now, there's a company in China that can print 10 houses in 12 hours out of cement, 600, 700 square foot homes in 12 hours. And then there's people that are working on nano-sized particles. They're printing with photons. I mean, so we have an amazing range. Airplane parts, a 30-foot titanium piece has already been printed. So, there's a large spectrum of what's being happening, and that's the interesting part is everybody's running in their own direction and using their technology for different means.
And as we talk about the evolution of technology related to computers and so forth, we know that if we go back 30 or 40 years ago, nobody was thinking about this kind of thing. They were just at that time getting used to computers, desktop computers. And then about 20 years ago, the internet came along with the dot-com explosion in about 95, 96. I remember then it was a novelty to be able to go to your fully wired desktop computer and order a pizza online. Everybody thought that was really cool. Today, that's nothing. Now you could buy a printer and print the pizza and eat it at home. You wouldn't have to order it. So using that as sort of the jumping off point, what will we be looking at in terms of everyday occurrences with 3D printing in the future?
Well, I think everybody's going to use it in their own way, but I do agree that the time frame is very similar to probably when IBM had the $100,000 big machines inside corporations and Steve Jobs was starting out with his wood printers, wood computers, because in fact there are wood-based printers right now out. So it's that time where the world's still ahead of us, the technology is still rough, but magic, and I think everybody's really looking towards the changes that are coming. We will be using these in our home to build toys and things for ourselves, but there'll be a lot used in manufacturing, personal hobbies. The way I look at it is, don't ask me what it's for, tell me what you want to do with it, because it's pretty much good for anything. Anything you do, that's what it's for.
All right, well, let's talk about the impact of 3D printing on large-scale manufacturing. We know that for the last 25, 30 years, all of the large-scale manufacturing has been pushed overseas to places like China, and now it's moving down into Vietnam and into Cambodia and other parts of the Middle East and into Brazil and so forth. What will happen to those large-scale manufacturing industries once we fully implement 3D printing across the board? What will the impact be on the supply chain, for example?
Well, it will affect everything, as in manufacturing especially. However, big manufacturing is not going away. There was always a place for large volume. What this is good at is manufacturing is good for making a million of one thing. This is good for making a lot of ones, but making a million different independent, unique things. And so there's always going to be a different state. So manufacturing will not be going away, but what we will be gaining is small manufacturing in the United States. It's already coming up where little toy companies are popping up, or people are making parts for the medical industry, but they have a printer and a small shop, and they invested in one machine, and they're running it, and they've started a business around that. We're going to see a lot of homegrown businesses, and that's where the industry, and that's the middle America that's really going to pick up.
And how will this affect the job market? People that do work in manufacturing plants, there's probably going to be some disruption in the job market to some extent in that area, but what will be the new jobs that will be created with 3D printing?
Well, it's already having a great effect in my hometown of Harrison, Ohio, which is in the middle of the country, and small town America is really having a great boom right now. So, for example, Louisville, Kentucky has a giant 3D printing facility, and they're hiring people to work on parts that'll be in refrigerators. Youngstown, Ohio just got this great place in that's sponsored by the government. There's other companies all building in the heartland where there's talented people who are out of manufacturing jobs, just waiting. So it's going to be great for jobs, and especially where we need it, because there are people being hired right now in Ohio, Kentucky, and Indiana, and it's great.
Well, let's talk about it in terms of fulfillment centers, because Amazon has a model now for book publishing. If anyone goes to Amazon.com and orders a book, there's a good chance that that book will be printed right after you order it, because that happened with me recently. I ordered a book, it was printed that night, it was put in the mail, and I received it within 2 days on my doorstep from a fulfillment center that was probably 50 or 60 miles away from my home. So is that an example of how fulfillment will work with 3D printing applications as well?
Yeah, we're already seeing a lot of examples of that. The two kind of main companies that you can talk about now are Cubify and Shapeways, in which you can go there right now, go online, find something you like, hit the button, they will print it, and they will send it to you. And the person who made that file will get a little revenue from that. But Amazon is starting their segue into it. In fact, they have a whole 3D printing segment now on Amazon, but they're not doing the printing themselves. So it's still other companies putting their 3D printed products on Amazon, and Amazon's not doing the service yet, but I would not be surprised if they jumped in on that. They're pretty smart people.
And what about service centers that are rented out to folks that need to use a service center to develop a product line?
There's certainly services now online where you can get help, but also there's maker spaces and hacker spaces that are coming along where people in the community will get together of like mind and they'll play with their 3D printers. And that's where you're getting also a lot of kind of collaboration amongst people, just kind of people coming together to make a robot, but also make a product to start a business.
What about entrepreneurs such as yourself? What does it cost for someone to get into this market, if you want to call it a market? What is the cost and what do you have to be aware of when you do make that step?
Well, there's a lot of things to consider. I mean, the technology is different for each machine. You really need to have a consideration for what product you're making matters about what machine. However, I would say generically, if you have a printer and you have a cool product, you right now can print it and put it on Amazon today, and it will be on the web right next to a product made by a giant company. So you have the ability. It's just what products are kind of ready today. Some machines are too expensive, and not everything is possible yet, but it's coming.
We're going to talk extensively after the break about your journey into 3D printing as a toy designer. And you've brought the samples. We've seen some of them already. We're going to look at some more of them after the break. But for you, why did you get into the toy industry?
Well, I kind of stumbled into it. I got really lucky. I ended up going to a school that was very near Fisher-Price. And they came down, they did a project. I ended up at Fisher-Price completely by accident. But it fits my personality in that I'm a designer. I've always liked to solve problems. And toy design is solving really fun problems.
And the name of your company now is Insanitoy?
Well, I have a couple companies. Kram is my main company that I do everything under, but I'm starting a toy company called Insanitoy, in which I'll be selling items like this, the 3D printed items, online.
You've got one of them here that's a big version of the cheetah that we looked at earlier. Let's take a look at that one.
Yeah, that's sort of the mega deluxe one. I just want to print them in every size and I can, because I can.
And so how would you compare this one to the smaller ones in terms of the process and development and so on?
Well, that's one of the neat things. In fact, this and this are really close to the same. And this, except this one has some rubber bands added just to make them move a little bit cooler. But essentially, this is the same machine and the same file, essentially making something really small and really big. There's kind of been never ability before to say, hey, I've got a product. What size, what material do you want it in? And so that's what I'm doing. I'm just seeing how far I can push it.
We just have about 30 seconds before we go to the break. Mark, if someone is watching this show and becoming inspired, what kind of financial outlay should they be considering to get into this field?
Well, there are machines as cheap as $500, but they're going to act like a $500 machine. You have to decide kind of how much you want to invest in if you're taking it serious as a hobby. You can get into a hobby around $500, $700. We're really talking about maybe a couple thousand, $5,000 to $7,000 if you want to get a nice high-grade machine. And they go up to a couple million if you want to get a metal printer.
Okay, on that note, we're going to go to the break. Stay with us. When we come back after the break, we'll take a look at some more of Mark's fascinating toys. Stay with us.
Make a difference in our future by researching and helping to preserve our natural resources. The wide variety of careers in this field will have a huge impact on our lives while using the principles of engineering, chemistry, and biology to help find solutions to environmental problems. You could be a part of this exciting field with a degree from Cal State Long Beach.
Hello and welcome back to Talking Points. I'm Dave Kelly. My guest today is Mark Trageser, and we're talking about 3D printing and how it's revolutionizing the industries of design and manufacturing. And Mark, before we went to the break, we were talking about the fact that you have a company called Insanitoy, and also your main company is Kram, which is a toy manufacturing enterprise. You've brought a number of samples to complement the ones that we saw earlier in the first segment. Let's go ahead and get started with this first one. This is another cheetah, it appears to be, but this one lights up. Tell us about it.
Yeah, I mean, it's basically the same file as the last one you saw before the break, but this one I figured might as well add some lights because now it's more of a desk lamp and just it has a really cool glow. You can also make it change colors and stuff, but you know, simply by adding some electronics, I've given it a whole nother life.
And it does light and it changes colors and does all kinds of things. You also have some other designs you want to show us. Let's talk about some dinosaurs here. What do we got on the dinosaur?
Yeah,
realm?
So in this product, what I'm using, I have 3D printed parts, which are the green parts, and this is more of a kit. You'll have rubber bands at home, or maybe I'll send you the rubber bands. But it gives it a feature. So now we can have a whipping tail, we can have a jaw that bites my finger, and it just gives it a little bit more character and a little bit more posability. So that's why I added the rubber bands to this guy. We've got another one that uses similar technology, but in this case we're making a character. So he's got a chopping axe, and he's got a little stabby blade, and he can bite my finger too. But the idea is this is more of an action figure. And again, you can put it together, and it has features. But these parts are only held together by the rubber bands. There's nothing else holding them together. And we've got another little guy. This one's a little simpler. But again, these are all using rubber bands.
Okay. You've got another dinosaur I noticed on the corner of the desk.
So this dinosaur here is also similar. We've got some 3D printed parts, but in this case, I use a bendy wire that I get at Home Depot and some tubing, just because it fills it out and gives it some fun color. We have some rockets too. This one has some lights in it, multicolored rocket just because it's fun. But some of this stuff over here is the more unique.
Okay. You're going to show us some vehicles here that have the moving parts and the wheels that turn and shock absorbers and the works.
Yeah, one of the neat things about this technology is because it's different, you're able to do completely different things. So this vehicle was printed assembled. It came out, they kind of shook it off, and the wheels were rolling. And in fact, it has a little suspension in it, so it actually has a little bit of spring give here. Now this is the same exact file, but from a different machine. So it's bigger, a little bit more robust, but again, the same file, two different parts. And this one is really fun, because look how complicated this is. You ended up, this is printed again, fully assembled. The tire spins, there's a shock absorber with a spring, and all these parts were printed exactly as you see them. That just lets a designer have a lot more fun. I'm not worried about how it comes out of the big steel tool over overseas factory. I can have anything my brain thinks of, and it comes out in really neat ways. And this one, again, has like a little shock in the back, which actually gives it a spring suspension. This is stuff that's simply never been done before, and it just gives me as an artist more opportunity to play and make something cool and new.
Okay, and you've done some other things. You brought something as well that's what you refer to as the creepy mask.
Yeah, well, actually for Halloween last year, I decided to go as myself. What it is I actually went for a CAT scan. And this was just because I went to the hospital and needed a CAT scan for something. I was able to get the data. There was a software online for free. I took that data, it made it into a 3D file, and I was able to print myself. And it's just kind of weird that from those files, I'm able to end up with something like this, where in the past, I would have had to have a sculpture, and it never would have looked like me. And it, like I said, it just kind of weirds me out every time I see it on myself.
So that's a new industry, creating your own clone, I guess.
I could imagine a Halloween party where everybody goes as somebody else. I could come as you.
That would be scary. Let's talk a little bit about the files and data and so on that you just mentioned. You managed to collect the file data information from the scan that you had done. You created the mask from that data. That also applies to the creation of toys. We've talked so far about you being the creator, you being the designer, the inventor, and so on, and you also supplying the manufacturing, whether you do it with your own machines or send it to another machine to have it done. But in reality, you could actually just send the data to someone who has a printer at home, and they could just take the data that you send them and then create this on their home machine.
Yeah, in the same way that when MP3s were coming out, files were kind of getting shared around and nobody quite knew what to do with them. We're in that moment now. There's 3D files coming out. So some places like Thingiverse are giving them away for free. You can go to thingiverse.com today, tool around, see a bunch of really neat things that people made, hit the button, download it for free, and print it on your printer right then and there. However, there's going to be a business model where somebody's going to sell them. So for $1, you'll be able to buy that bottle opener that you wanted at home, or that new spoon, or the replacement part for your camera, that, the remote control battery door that you lost. That'll be online. You'll hit the button $1, and you'll get the file, and then you'll print it yourself.
And you mentioned that this is sort of an equivalent of iTunes in 3D printing mode. What did you mean by that?
Well, I'm pretty sure that somebody's going to take these files and put them together in a nice, orderly fashion, because they are out there, and people are giving them away for free, but that won't continue. In the same way with music files. Napster went away because they just made it, iTunes just made it so much easier. You got it the file you wanted, you knew it would work, it was by somebody reputable because maybe there was a review on it, and there actually adds some legal protection too, because I want the designers to have protection, but I also think it's neat if people want to give away stuff too.
Well, let's talk about product liability, since you're in the toy business, and toys are held to very rigorous safety standards, which they should be, because we have young children and we don't want them swallowing parts or somehow being endangered by toys that don't hold up. So how do you deal with the product manufacturing liability issues in terms of mass distribution of toys?
So for now, what I'm doing is I'm simply staying away from younger ages. Because if you take basic safety standards for toys, really you shouldn't be giving a small part to a child under the age of 8, and you probably shouldn't be giving something to somebody under the age of 13 if you really don't know what it's for. At 13 plus, the child is responsible for their own actions. It's really not the material, so I would be willing to print a cereal bowl on my machine at home and eat right out of it. The problem is, what if somebody breaks the spoon? Now we have a quality issue of that, that broken end. And that's really the difference. And so toy standards are high for a reason, and they should be obeyed. So for now, the best thing to do until this is getting further down the line is just to kind of stay away from the younger toys. So we'll make toys for the older kids to start with.
Okay, well, I want to talk about your journey as an artist and in the toy industry. And on your website for Kram, you have a list of reasons why you do what you do. We've already seen what you've done, but I want to understand why you do this in the first place. And you said on the website, as an artist, I cannot help but create. Now, what do you mean by that?
Well, I think that if you look at an artist, I think they just want to make something neat and to offer the world. Somebody wants to make a beautiful painting. There's not usually a reason for doing that other than they just want to do it. They have it in their heart. Whereas a designer, I think, often will say, I have this purpose. I want to solve this. I need a bridge, so I want to design a bridge. And to me, an inventor is maybe a little bit of a designer and an artist kind of mushed together, because some of it is, I see a problem. I want to solve it. Another part of it is just, I'm having fun. I can't help myself.
Well, that leads to the second point you listed on the site, where you said, as an inventor, I desire to improve the world and I love to tinker.
Yeah, I mean, it's just fun to solve a problem. I'm very proud when I make a child smile with one of my toys. If you're empowering a child to learn something and to have fun and to maybe work with their family member, that's fantastic. And I think one of the neat moments right now is with 3D printing, you're seeing a lot of parents and their children both being excited by the technology. And for the first time ever, you see them both kind of coming to the table. Neither of them know about it, and both of them are excited about it. I see a lot of that happening now, and it's great for family bonding and also just the education of our country, which I think we really need to improve.
We're going to get to education in just a moment, but the third point you mentioned was, as a designer, I enjoy the challenge of working through all the twists and turns of design and development, and I enjoy working with a talented team to make big things happen.
Well, when I started, I was always working at a large corporation, and I really benefited from that because when I made a toy, it went everywhere. I'd find it all over the planet. And that is much more powerful than me making a couple and selling them, at a flea market. Now, that's a fine job too. It's just I'm really excited when you work in larger teams. And I think that there's a benefit to being able to do that. And this technology, if you put it in, get more people together, then you really can do larger things and make large companies.
And you talked about education a moment ago. You mentioned it. I said we'd come back to it. Well, we're here now. And your final point on this was, as a teacher, I want to pass on this passion. And you certainly have a passion. We've seen it today. How do you intend to pass on that passion?
Well, a lot of what I do is I just talk to people and I go meet with people and try to work with them. But honestly, you don't have to inspire the kids. It's the adults you've kind of got to catch up. The kids, you show them a 3D printer, they never ask what it's for. They tell you what it's for. They go on and on and on and make requests. But it's great to see them really working. But then you kind of help direct them into, hey, maybe this is a better project to work on than that one. Because it's important to not just play with it, but to really make sure it's a learning tool. And this is a powerful, powerful learning tool.
You're also an artist by trade. You don't just make toys, you make other items as well. What are some other things that you do as an artist?
Well, I have, as an inventor, I kind of can't control where my mind goes and where my ideas come. Sometimes they just come up. So I have products, like I'm working on storage bins with one company that'll be coming out to the market. I'm also doing things for the house. Like I just like decorative items. So I have some vases that I've been making to put in my house and some lamps, because if you put a light, you saw the cheetah with a light. That's a pretty fun lamp already.
So it's practical application as well as the fun.
Sure, why not? I mean, to me, if you solve a problem, that's great, and if you're having fun, that's great. It all just betters the world if you have a product that functions nicely instead of just another widget.
Well, let's talk more about the biomedical field. We touched on this earlier about how the biomedical field is involved in this, but what can they do today? I'm reading about the development of miniature kidneys and miniature livers and that sort of thing. How is that possible?
Well, right now the medical industry is one of the most advanced because they are putting a lot of money into it. So there are bone transplants, there's 50 or 60,000 printed titanium bone transplants that are already out there in the world. But the printing of organs is really exciting because the first person to really kind of be known for it, Dr. Anthony Atala, he was a transplant doctor and he was tired of watching his patients die because he couldn't get a transplant kidney. So he's like, I'm just going to start making them. And he just started to try. Now his first machine's amazing because he can print skin on you. So imagine if you've been burned, normally they have to take skin from one place and put it in another place. That's horrible. That's painful. He makes a machine, he's going to take some of your skin, he's going to shave it off, he's going to put it in a jar, he's going to make a little bucket of your skin magically somehow in his laboratory, but he's going to then print it on your hand. He can print your entire back in 40 minutes is what he projects. He already has a machine that he's made for the Navy. So he's going to be saving our soldiers who have been burnt, or the people out there who've been injured. He's going to make their lives better.
So there's an organic component to this, obviously.
Yeah, he's printing with your cells. He took a normal inkjet printer. Instead of ink coming out of it, it's your cells going right onto your body. Fantastic.
We just have about 30 seconds left. This show has really flown by. I want you to say in 30 seconds or less, what are the limitations? We talked about the sky being the limit. There are some limits. What are they?
Well, right now there are a few technical limitations. I mean, there's cost and there's size, but to me, honestly, I see a giant pile of gold. There are, maybe the gold's dirty, maybe the gold is heavy, maybe the gold isn't a ruby, but it's gold. So anytime I hear complaints, I look at what's beautiful and what is there, because there's a lot of power there. Yes, there's some problems. You have to be intelligent how you use it now. But really, the sky will be the limit. All the no's are gone from my world.
Very good. And thank you so much for sharing with us your philosophy and also your great inventions.
Thanks so much.
And thank you for joining us for this edition of Talking Points. Join us again soon for the next episode. Until then, I'm Dave Kelly. Have a nice day.